Hello students, in this video we are starting some important organic name reactions and the Barton reaction is one of them. It is a very important reaction from the point of view of the exams. Several time questions are asked related to this reaction. Actually it is a photochemical reaction that involves the 1,5 hydrogen shift. It means the hydrogen is here shifted from one position to the fifth position, and as a result of this reaction an alkyl nitride is converted into a delta nitroso alcohol. In actual conditions what happens? A methyl group that is present at the delta position to the OH group is converted to the oxime group. Suppose there is a OH group here and its position alpha, beta, gamma and delta. This is the carbon atom and the three hydrogens are attached here. So that hydrogens are delta hydrogens. So one of them, this hydrogen can be shifted here. Firstly, what thing happened? This OH group should be converted to the nitride group because the reaction is not possible with this OH group. The reaction is only for the nitride group. So we will convert it by the nitrosyl chloride into a nitride group. And then the reaction proceeds. This is our reactant. This is the reactant that we have to convert in the product, ONO group. And if there is a delta hydrogen present, it means alpha, beta, gamma and delta. Here any hydrogen is present, then in the presence of the light, what happens? This hydrogen is shifted here and this NO group is shifted here. And as a result of the rearrangement, we get a oxime group at this carbon atom. It means we get a delta nitroso alcohol. The alcohol becomes as it is. Here was the OH group present and same OH group is present here. Only what happens? Here at the delta position we get a oxime group. Okay, now we see the mechanism of this reaction. The first step in the mechanism involves the homolytic fission of this ONO bond in the presence of sunlight. As a result of this sunlight photoirradiation, what happens? Homolytic fission takes place. So there are two electrons of sharing. One electron will go here and another electron will go here. So there will be formed two radicals. One this radical and another this. Now what happens? The fission of this bond will take place. This hydrogen will take its electron and one electron will come here. So a radical will form here and this hydrogen will attack here. So a bond will form between them. Suppose there is a radical and then this is a radical. Then this radical that is formed and this radical will form a bond here. So a bond is formed here and a radical is formed here like this. Now this radical and this radical, it can react. So it will be like this. A bond will form like this. So we get this type of bond. Now this is in the keto form and it will undergo tautomerism. So that the bond from here will come here and we get a hydrogen shift here. So we get the oxime product. So this is the oxime that is formed. We can see its position, alpha, beta, gamma and delta position. So it is a 1,5 hydrogen shift. We can see here. Okay, now we see the examples of the Barton reaction. The first example is this. And the similar example has been asked in the GATE 2010 exam. You can watch there. So in this example we have given this compound and when this compound is treated with NaCl, then pyridine and then with sunlight. And then when it is carried out the acid hydrolysis in the presence of acid, then what happens? What is the product? We have to find out. Okay, then we can see here that this is the OH group that is present. And when we react it with NaCl, then it will convert into ONO group. It means nitride group. Now what is the conditions of the delta hydrogen atoms? The delta hydrogen atoms are present here, alpha, beta, gamma and delta. One delta hydrogen is present here and another alpha, beta, gamma, delta. Another is present here. But what we will see here? We have to see that this OH group is inside is below the plane. And we know that the Barton reaction, for the Barton reaction, the essential condition is that the delta hydrogen should also be in the same plane as that of the OH group. And here this is the below plane OH group. So the hydrogen atom should also be below the plane so that the reactant can easily react with each other. The two atoms can react with each other. So here this hydrogen will be present at the upside of the plane, above the plane. But here we can see that these hydrogen atoms are present below the plane. So there are more probability of reaction of this OH group with this hydrogen. So it will react with it. As a result of it, the hydrogen will be shifted here. It means to the ONO group. Here a ONO group will be formed and the hydrogen is shifted here and NO group is shifted here. As a result of this, we get an oxime here. And this type of oxime is formed. So this will be the major product in this case. Another example that has been come in the csirnet December 2016. And in this example, this is the reactant that we have given. And when it is carried out, the reaction with the sunlight and then hydrolysis, and we have to find out what is the product, and we have given the 4 different options. Now same condition is here. We have given the ONO group and we have to firstly see the delta hydrogen atom. Now see here, alpha, beta, gamma, delta. One delta hydrogen is present here. Now another see, alpha, beta, gamma and delta. Another delta hydrogen atom is here. Another see, alpha, beta, gamma and delta. Another hydrogen atom is present here. Alpha, beta, gamma and delta, and another hydrogen atom is present here. So 4 different hydrogens that are at the delta positions are present. But we have to see the planarity conditions. It means this ONO group is below the plane. So we have to find out the delta hydrogen that is present below the plane. Now in this condition, this hydrogen will be present below the plane. So it will react with this ONO group. So what will happen? We can see here at this position, a double bond NOH group will be formed. It means we can write like this. Here OH group will come and in this position a double bond NOH group will formed. Now this will undergo the hydrolysis. As a result of this, a O group, a keto group will form here. It means this product, you can see this product will be formed and this will be our product that will be formed. So our option A will be the right option. Okay, then the next example is from the NET June 2016. Very simple example and you can quickly answer it. In this is the reactant and we have to see its photoreaction. So there is an ONO group present and we have to see its product. So firstly identify the delta hydrogen, where the delta hydrogen is present. So alpha, beta, gamma and delta. Delta position is this. So at this position the hydrogen will be abstracted. So this NO group will be shifted here and the hydrogen will be shifted here. So this is the product. D answer. This will be our product because OH group will be formed here and NO group will be formed here. So simple. Only we have to identify the delta hydrogen atom and we have to put the NO group there. So very simple and you can quickly answer it. Okay, the next example is from the GATE 2012. An example is this and we have to see its photolytic product. So this is the ONO group, and identify its delta hydrogen, alpha, beta, gamma and delta. One delta hydrogen is present here and another alpha, beta, gamma and delta. Another delta hydrogen is present here. Now which hydrogen will be abstracted? So obviously this hydrogen is most approachable by this ONO group. So this will be abstracted, and as a result of this the oxygen group is put here. So the oxygen group is introduced here and we get this product. This will be our product.